Hello everybody and welcome back to my channel. Today I'm going to be working on a fast-slow pointer approach in order to solve the middle of the linked list LeetCode problem. And without further ado, let's move to the board. Here we are, we've got the number 876, which is called middle of the linked list. And the question states, given the head of a single linked list, so that bit, and single is important because it means that it points only to one direction, return the middle node of the linked list. So we need to return that node. And if there are two middle nodes, aka we've got an odd number of nodes, return the second middle node, which is that bit here. Okay, let's move to the test case and see how we can implement that with a quick graph. Okay, let me grab the pen. We've got the test case 1. And what I'm going to do is I'm going to create two pointers. That's going to be the slow and the fast. And both of them are going to be pointing to the head of the linked list initially. And I'm going to loop over that linked list until the fast pointer the fast.next reaches the end of that. So the fast.next is null. Okay, so first iteration, we move the slow pointer one position to the right. That happened, yeah. One position to the right, one position to the right, and the fast pointer two positions to the right. And as we can see, the fast.next is defined and this is that node. So that means that we need to continue iterating over that linked list. And iteration number 2, slow pointer is now moved here. And the fast pointer moves here. So we need to check if the fast.next is null, which is true, and because that's true, we are going to go out of that loop and we are going to return the slow pointer. And as you can see, the slow pointer points to the middle of the linked list. Super. What's going to happen if we have an odd number of nodes then? So same idea, we are going to have the slow pointer and the fast pointer. First iteration, slow pointer moves here, fast pointer moves here. Or the fast.next is defined at this node, so that means that we need to continue iterating through that linked list. And the second iteration is gonna be the slow pointer points here. And the fast pointer now moves to this position. And we need to check if the fast pointer, the next node is defined, and it is this node. So that means that we need to continue iterating. And in order to do that, we are going to point here with a fast pointer, which is the null. And the slow pointer is going to be pointing here. And of course you can see that this is the correct result when we return it. Something that I forgot to mention is that we need to, in order to handle this situation, we need to have two checks. One for the fast pointer .next to be different than null, and one for the fast pointer to be different than null. Sweet. Okay, I hope that I haven't confused you too badly. And let's move to the LeetCode website in order to write that down algorithmically. And we've got the slow pointer, which is going to be a head, and we've got also the fast pointer, which is going also to point to the head of the linked list. And as I said few seconds ago, we need to create a while loop here, where we are going to check that the fast and the fast.next are not null. And if that happens, that means that we need to move the slow pointer one position to the right, so slow is equal to slow.next, and the fast pointer needs to be moved 2 positions to the right. Alright, and at the end of the loop we need to return the position of the slow pointer in order to return the middle of the linked list. I love semicolons. Let's run this code. Great, and if we submit that, sweet. Alright, that was a fast for today, guys, a fast video, quick video, short video. I hope you enjoyed that. If you like that, please give that a thumbs up and share it with your friends. If you haven't subscribed to my channel, please do that, it's gonna be super helpful for me. And catch you in the next one. Cheers.